Hello student, today I am going to discuss practical of class 11, the experiment number 2b to find the force or spring constant of a helical spring from the lot extension graph. For doing this experiment, we need the apparatus, a spring, a rigid support, a 20 gram or 50 gram hangers, and a number of slotted weights and a vertical meter scale, a fine pointer and a hook. So what is the theory of for this experiment? The one lot is suspended at the free end of the spring, then it increases its length by L. That is the statement of Hooke's law. Extension is directly to the lot, or lot is directly to the extension. So F is proportional to L, F equal to KL. K is called spring constant. That value we have to find out. The value we have to find out the value of K. So what is K? That is called spring constant. It is defined as the force required to produce unit extension in the spring. Yet in unit extension, what is the force acting? That is called force constant. For doing the experiment, this is the apparatus for this experiment. So here at the free end, load is hanger. This is the hanger. Load is attached at the free end, and this pointer measuring the value of the scale, which gives the extension of the spring. So you see the table. Some probable value of this table I have given here. 20 gram load is attached. There is extension 6.5. 40 gram extension is 8.1. 60 gram 9.8. 80 gram 11.5. 100 gram 14.2. So this is increasing water. When decrease the load, so 100 gram is 14.2. When decrease another 20 gram, it becomes 80 grams, so 11.5. Now 60 gram 9.8. 40 gram 8.1 and 20 gram is 6.5. So now we have to take the mean value of these two values. So you just take the addition of these two divided by 2. So sum of these two divided by 2, that gives 6.5. Yes, 8.1, 9.8, 11.5, 14.2. To find the extension, you just subtract 6.5 from 8.1, that extension is 1.6. Again you subtract 6.5 from 9.8, then the 3.3. Again 11.5 minus 6.5 is 5. 14.2 minus 6.5 is 7.5. So these are the values of extension corresponding the weights. 40, 60, 80, 100. So this value we have to plot on the graph paper. The graph will be load versus extension. So if you plot the graph, your graph will be like this one. So this 20, 40, 60, 80, 100, 120, and extension is y-axis. So 1, 2, 3, 4, 5 up to 9. Now, so different values, so 40 gram, 60 gram, 80 gram, 100 gram. So all the values, when you plot the graph, your graph is like this. So from this graph, we have to take a point. Say we are taking point A. Corresponding to point A, so its load is load is 90 gram and corresponding extension is 5 gram. Okay, so corresponding to point A, so applied force is 90 gram. So we have to convert into the dyne. So 1 GF is 980 dyne. So GF, instead of GF we have to write 980 dyne. So it values 88,200 dyne, and corresponding extension is 5 centimeter. So since force constant, force per unit length, so therefore K equal to F by L. So force constant or spring constant of the spring, K equal to F by L. So 88,200 divided by 5, that is 17,640 dyne per centimeter. So the spring constant of the given spring is 17,640 dyne per centimeter. This is the required value for this experiment of spring constant. This is the the value of spring constant of the helical spring. You see, so this spring constant of the helical spring is this 17,640 dyne per centimeter. So in the practical record book, you have to write in details. How to write, I am telling you. Since you are first time you are going to write, so first you have to write aim of the experiment. So aim of the experiment you have to write to find the force or spring constant of the helical spring from the last extension graph. Then you write apparatus, then theory, whatever is there as it is you will write. Then you will give the diagram. So diagram you have to give in the back pages of your practical record book, back pages, and rule pages. In the rule pages you write this apparatus, aim, apparatus, theory, all this thing you will write. And then also you have to write procedure. So procedure, whatever is there you write as it is. Now this is the procedure you have to write. After that, in the rule paper you have to draw this table. So this table, exactly you have to draw this table, and also you have to write this corresponding values. All is given here, the corresponding values you see. This is the corresponding, these are the values, probable values for doing this experiment, for the experiment. These are the probable values. So this value you have to write. After that, in the back pages, you have to draw this graph. You make this graph, and this graph you have to paste in the back pages of the practical record book. Then afterwards you have to write this value. This one you have to write corresponding to point A on the graph. So you have to write this value, F equal to this, and result and precaution, whatever is there, precautions. So loading and unloading of the weight must be done gently. So all this below, and source error also, this support may not be rigid, the slotted weights may not have standard weight. So all this value you have to write. Thank you.